by Jaakko and Thomas. So I give you the floor and let's start. Thank you.
Thank you, Eleni. So Jaakko Kuusisaari, my name, and working as a solution sales lead, leading the sales operations related to our biomaterial processing and products research and solutions. And Thomas will take over after a while, and maybe at that point Thomas can present himself. So glad to be here. Thank you for this opportunity to present this this case to this audience. Just checking, can you hear me loud and clear? Good?
Yes, yes, we do. Thanks.
Okay, thank you. So let's move on. Starting with a brief introduction of VTT. So VTT, member of EARTO, as we heard, we are a state-owned independent research company here located in Finland. We are quite an international player. Actually, roughly half of our business is with Finnish companies and the other half with international companies or with companies having headquarters outside of Finland. Mostly in Europe, North America, Latin America, somewhat in Asia as well. We are about 2,400 people, very diverse and very international personnel. Next, please. We collaborate with our customers basically in three different ways. Through what we call customized partnerships, which in practice means one-to-one commercial project. Then within various cooperative or consortium projects, typically applying for and working on public funding coming from EU in many cases, or national funding agencies like Business Finland. There's some background noise there, maybe it was temporary. And we're also part of multiple innovation ecosystems. And what comes to these one-to-one commercial projects or customized partnerships, as we call them, that other type of collaboration model that the case today also represents, there are maybe certain points worth mentioning. When we work one-to-one with customers, the foreground, new IP or IPR created in the project and the outcomes belong to the customer. So the customer owns the result when we are working in one-to-one direct commercial project. This is a clear model that we apply. We also have some existing IP. VTT has done a lot of research on our own as well and patented various technologies throughout the years. This IP is always open for licensing to our customers in a fair and reasonable licensing terms. And then maybe the third thing worth mentioning already here is that one of our main assets, in addition to our brilliant research personnel and our scientists, is our laboratory and piloting infrastructure. So we have various pilot centers with the various type of pilot lines that we can accommodate and customize also according to the needs of the customer projects. And we can also build new pilots when needed by a customer project, which is something that we also did in this case. Next, please. This slide here is illustrating the let's say, the upscaling path from low technology readiness level all the way up to commercialization. And the area where we typically operate is there between or starting from TRL 3 to TRL 7 roughly, varies of course a bit, but basically those are that is the range where we're working, and that is the range which is often called as a valley of death, because that's the area where the risk and unknowns are still very high, because there's a lot of development and validation to be done, but the need for research and piloting assets is already high, meaning that the cost of infra and the cost that has to be invested in the equipment, if you're building them for the case, is already high. So it's kind of an area where risks are high, but costs are already getting very high as well. And what we've done, we've pre-invested in the infra and the pilot lines and the capabilities, so we can offer those to be used together by our customers, who can then focus on the development upscaling project while we provide expertise and the infra for that. Next, please. At VTT, we have 3 business areas: carbon neutral solutions, digital technologies, and then sustainable products and materials, which is presented here. And not using more time for this, just showing that we have a very broad portfolio of different competencies, which also synergistically support each other. So in this project, we are representing this high impact renewable materials area, but we are also collaborating with the other research areas and using the skills across to be able to provide the customer with the best possible skill set and facilities for the project. Then maybe we take the next one. Yes, this is more like an intermediate slide. So we believe that when exceptional business ideas supported by science, then we get true innovations and impact. But let's get to the next one, which is the actual case, kind of an overview. This is my last slide, and then I after that hand over to Tuomas. This case was about developing a new technology, new production line for a new type of fiber-based products to come up with high quality, sustainable, commercially solid solution for the packaging market. And also hearing my own voice echoing back now, it's a bit annoying, but let's not mind it. Now it's away. And one aspect, of course, which Juho and Katarina will tell more about, is that the production line as such was aimed to be having a very high level of automation and efficiency. This is a perfect case for us in a sense that, if you remember what I told you during the previous slides, is that what we want to do, what we want to achieve is a technology to get commercialized and to really create impact in the market. And here, actually, during different phases of this project or initiative, a program rather, there were actually multiple projects in a row. That's exactly what we are doing. It's also great. We are collaborating with actors in the value chain. So in that sense, technology provider and then Metsä as a fiber product developer and vendor, and supporting these actors or our partners in a joint effort to reach the goal. So here also we went from lab to pilot to multiple phases, and also in parallel, actually, or in cycles rather, completed intermediate results. First lab, then building the production line that is now located there by Metsä, which is now being used, and future plans exist to go forward from there, as well as another development environment that we set up then basically from scratch to be used also in parallel for development to support the other line, or to also develop new functionality and new solutions, or extending this technology that has been developed here. So that was also something where I would like to believe our agility and capabilities played a crucial role, that we were able to build a research and development platform, the infra and the environment from scratch to be matching the needs of this project and further development. I've been using like 10 minutes now, so maybe it's high time to hand over to Tuomas. So will you take over, Tuomas, from here?
Yes, definitely. Thank you. We can go to the next slide now. Thank you. So my name is Tuomas Turpeinen. I'm the project manager for this project at VTT side, and here I will briefly go how the story has been going from our perspective. So here is the project timeline, and all started in 2020 when Metsä Group and Valmet discussed about the initial idea and decided that they should start the development project. In 21, VTT joined in, and we provided access to our piloting capabilities for testing, and also helped to develop the industrial process itself. In 22, we continued the lab research, and as a result, the Valmet launched the demo plant in May. And after that, we continued to provide the research support, and the collaboration between Valmet and VTT continued with exploring the commercial potential and upscaling of the process. In 24, VTT finished building a new R&D device for this sample for Valmet, and the device supports the further development and also opens possibilities for other companies to test their ideas with this Valmet concept. And also in 24, Metsä published the Muoto product, and note that this is only 4 years after the initial idea, very fast process. And the research still continues towards the global market expansion, and Valmet and Metsä are here, then they will describe in more detail how it goes now. The impact of this work can be summarized in 3 main points. So first, we now have a product that truly meets today's market needs in environmentally friendly way. Second, the production process is fast and it's highly customizable, which makes it possible to compete with the existing solutions, also with plastic and, for example, aluminium. And third, this product has reached the market in record time. So we can go to our next slide now. So how was this fast development possible? So my answer is that you have to join the right partners. Valmet is very good in process industry. However, there is one new element in the technology that Valmet is now developing with this product. They are using fiber foam instead of a traditional water-based slurry, and VTT has around 20 years of research experience with foam-based processes, and including many scientific publications. And this allowed us to provide strong support for process development when using the foam in this process. And in addition, we have an extensive knowledge on different fibers, additive filtration systems, drying or piloting at various scales, and so on. And because of this, we could provide Valmet with several years worth of research knowledge, which significantly shortened the development time compared to starting from scratch. And of course, the important factor behind this success was open and efficient communication between the all partners. Next slide, please. So thank you from the VTT side, and I will now hand it over to Valmet to continue the story. So you can go to the next slide again.
Okay, my name is Juho Pyrrö, and I'm head of Valmet 3D. Sorry, somehow it was muted.
Yes,
I don't know.
Now we hear you.
I was opening it, but yeah, now it should be working.
Nice.
Okay. I don't know if you heard anything.
We heard
No,
you
we
At the
didn't.
very beginning.
Okay. Okay, maybe somebody was muting me, but okay. But I'm Juho Pyrrö, head of Valmet 3D Fiber, responsible for the development and commercialization of this new technology what we are introducing today for you. We say that this is a disruptive innovation in the molded fiber packaging, and in this picture you can see one good example what we have been achieving so far. So the picture of our demo line, which is in operation in Metsä's Äänekoski mill here in the middle of Finland. Please, next slide. So a little bit background about Valmet. Maybe many of you know Valmet, but we are global leader in technologies for selected industries, very strong both in technology, but also in the life cycle services within these industries. So market leader in pulp, packaging, and paper and tissue, for example. And of course, we get lots of benefit in this kind of R&D projects, where we have lots of expertise, including automation-related capabilities and flow control solutions, etc. So 90,000 people, so you have always some expert in the areas where you would like to explore some information and so on. So that's huge benefit in this kind of fast-paced development project. In our R&D, we focus on the promotion of renewable materials, raw material, and water and energy efficiency, and these are very essential elements also in this new innovation. And circularity, of course, that's something which is connected, these renewable materials. We have some 34 R&D centers, and this demo line is one example of that kind of R&D center and pilot operation. Our spending in R&D was 123 million in 24, and we have some 1,400 protected inventions. Next slide, please. So some words about this project. So it started actually, I think the first discussions were happening in 2019, when Metsä was proposing us this kind of new idea and proposed collaboration here, and then Valmet was selected to be a partner in this development project then early 2020, and we started different lab studies and work and also did some commercial studies about this potential solution. And quite soon we decided that, okay, we need to build up a demo plan, so the lab results were promising, and we decided to build up the demo plan based on the developed concept. And this demo plant has been working as a platform for both companies to develop this process together, but then also for Metsä to develop the end products and us in Valmet to be a platform where we can test all the technological solutions what we are using in this innovation. And then VTT has been a very important partner in this. So like Tuomas mentioned, there is a couple of decades of experience in foam forming or foam-related processes. And actually, it's one core innovation in this and suddenly kind of a very nicely working solution in this molded fiber area. And it's helping us in many ways to achieve the cost-efficient, resource-efficient, and energy-efficient processes. I guess Katarina will tell more about Metsä's development, but demo line is used for pre-commercial testing of the end product, so kind of minimizing the market risks. And for us, it is the platform where we can minimize then the technological related risks. But I want to also say that this technology will be available for the global markets in the end. So today, the traditional molded fiber technology is many times coming from China or other Asian countries. So this is something new that we have, like EU-based technology supplier offering this kind of unique solution in the market, which is very competitive against the traditional technologies. Next slide, please. Okay, this is the picture of the demo plant location. So it is located in Metsä's Äänekoski mill in Finland. So it is very good location for that. We have, of course, good infrastructure there, lots of also other innovations to be in testing and piloting phase. And Valmet's key location is near the mill, so our people are doing their R&D work there on daily basis and jointly working there with Metsä's experts to develop this world kind of this unique innovation. Yeah, so like I said, it's used both product market testing and technology development. Next slide, please. So of course there are some, I would like to highlight that there are always some risks when you are jumping into this kind of large R&D project and how to handle those. So I have a few words about that. Please, next. So one important thing is that from the beginning, you recognize that what are the risks related to these processes, and you gather the best knowledge available. And when there was this kind of new elements involved, so we combined the forces. And obviously, Metsä is looking at the end product perspective, kind of what is the potential in the packaging market and what is required from that perspective. We understand the limitations in the technological side, and then VTT had this background in the foam forming. And we also made some studies together with some consultants to understand the market even better. So neither Metsä or us, we didn't have anything in this molded fiber area. Then scale-up risk mitigation, it's very important, and for that we got support from Business Finland, for example. So there have been this Expand Fiber and Beyond Circularity ecosystem projects, and very important for that. So there is plenty of different partners in top of VTT and Metsä with whom we have been collaborating, for example. And then next. And of course, it's always good to keep in mind the common targets and make the risk mitigation together and share those openly. Next slide. So there are some bumps along the road, of course, now and then. And in our case, we started in the midst of the pandemic almost. So there were like lots of problems with the supply chain related, so component deliveries and so on. But I think we're surprisingly fast during that time even. We made even some new construction of the new facility. Then the adapting of these industrial scale automation systems to lab machines, for example. So of course it's always a little bit trickier than just going straight in there. But we have lots of different process parameters which we can adjust, and that's very essential in our R&D work, and that's why we need this kind of systems. And maybe to give, if you put a next one, if I want to highlight something, so please, if you are jumping into this kind of large R&D project, so don't hide the problems, be open with your partners. Of course, you need some agreements back in the background, but it is so that you shouldn't kind of consider what agreements are saying on daily basis. You need to focus on your doing and work together openly and focus on the finding the solutions at the end. Next one. Okay, then a few words about the solution. So what we have been developing so far. We have the first version of the commercial line ready. It is a flexible and modular concept which has high automation level because it is targeting to the Western markets. And here, of course, it is important that you minimize the manual labor work. The machine itself, it's much faster than the existing traditional machines. So the high output, of course, helps in the OpEx side of the business. So this has very high potential for strong EBITDA profits and business at the end. But of course, in order to achieve low OpEx and business potential, you need to have also some innovations. In our case, it is, for example, this unique fiber layering, which enables us to make lightweight products, put for example, the chemistry where it is needed, and kind of optimize the product quality. And also helps us to achieve good operational efficiency levels. Next. Then I want to also highlight that this is in a way complete process and technology solution what we have been developing. So it is not just one part of the process, but we can offer everything. So from the fiber processing until the end of the line. And it is involving lots of new innovations. We are using this injection forming technology to make the fiber-based products. So something similar to injection molding process in the plastic industry. And these sustainable packages, of course, offer very competitive, good competition against plastic packaging and opportunity to reduce plastic packaging in that area. I trust Katarina will tell more about those end products. We are using additive manufacturing for the molds, what we are doing, and get lots of speed by using efficient dewatering enabled with these solutions. We have energy efficient process solutions with closed water loops, which is very important when doing business in Europe and North America. And automation is mentioned a couple of times, but also this digital side, so industrial internet traceability of the end products, etc. So this is bringing lots of benefits like high speed, these plastic replacement opportunities, strong EBITDA business opportunity, and it is flexible and flexible process which is suitable for wide range of end products. So we see this huge business potential for us, but still resource efficiency and safety are something which shouldn't be compromised in this solution. Okay, thank you, and I'm happy to hand over to Katarina, who will tell more about the end product itself, what we can make with this technology.
Yes, happy to do that. Hi, everybody. My name is Katarina Kemppainen. I come from Metsä Group, and I head the group R&D function in Metsä Group. So actually covering a lot of different kinds of R&D projects and innovation initiatives. But today here telling you about Muoto. But I have to mention there's a lot of other cooperation between Metsä and Valmet and Metsä and VTT, which we could also talk about. But today, of course, the topic is Muoto. And here just a statement to begin with, what is the solution to many future challenges? That's what we think. If we take the next one, very briefly about Metsä Group. What is Metsä Group? Metsä means forest in Finnish, so we are the forest group. We're very much rooted in the forests as the parent company is a cooperative of forest owners in Finland, 90,000 Finnish forest owners. And here you see the areas we have business in. So of course we need to source the wood and supply services to the forest owners. Then we make engineered wood products, LVL, plywood. We make pulp and sawn timber. We're the largest softwood pulp producer in the world. And then we produce a selection of high quality paperboards and also tissue papers, greaseproof papers. And we have production units here in Finland and Sweden and Germany and some other Central European countries, a bit also in UK. Here you also see Metsä Spring, the innovation company, which is part of the group structure, and Muoto project has been under development in Metsä Spring. Let's then dig into Muoto. So if we take the next one. And finally, getting to talk to you about the products. Next one, please. So our role obviously here is to figure out what is the product that we want to commercialize and bring to the market. And we have branded it as Muoto. Muoto means shape, so it's very descriptive of the product. And it's indeed a novel fiber product that delivers quality, efficiency, and reliability to various uses. And food packaging is a major area. And here you see one possible use for it. And as maybe you see, this is a packaging area where typically plastic products are used. But although it may look a bit like plastic, it's not. It's fiber-based and but very much able to replace plastics in this type of use. Then if we take the next one. So briefly telling you about the product series that we have launched. So we have uncoated series and then this laminated series, a bit for different uses. So the uncoated series is indeed uncoated, fresh wood pulp, no recycled pulp in there, and it's very much for food serving or takeaway, fresh produce, these type of uses. And although it doesn't have any coatings, it's still quite waterproof and greaseproof. So very good for many food service use as it is. It of course stacks nicely, and of course super important is that it can be recycled and that is also biodegradable according to industrial composting. So that's a great product for certain uses, but then of course there are some other uses where you might want like a modified atmosphere inside the packaging or this vacuum skin packaging. So maybe you need a little bit of plastics to enable even further use in food packaging. And then we have this laminated fiber series launched in cooperation with Amcor. And then we can easily go into packaging unprocessed or food or proteins or ready meals or chopped vegetables and these type of things. And of course, the packaging regulation very much affects the field and drives it to certain direction. And we think our products provide these new solutions that are compliant with the new regulation and maybe hopefully get some competitive advantage from the regulation as well. Let's take the next one. The focus has indeed been from our side on the product design, and that includes the recipe, what raw materials are used, what fibers and so forth. And then the design. What is the design that we want to bring to the market. Of course, we participate in the process development with Valmet as well a lot, but this is the area where we have the main role. We started from the easier shapes like these plates, and then have gradually moved forward to deeper and deeper shapes. And unfortunately, you can't get to touch and feel the packaging product here through the webinar, but it's really sturdy and very lightweight and feels very different from anything on the market at the moment. And as you see, the shape is deepening, and we have a few launches coming up as well later this year with these deep shapes. It is resembling more and more of these plastic products, which have been difficult to replace perhaps with fiber-based products so far. All right, let's take the next one. So what is then of course the need at this point of the development when we have a nice demo process, quite well already optimized, still some work to do there, but for sure the biggest emphasis needs to be on the customer trials. And this is in order to really validate the demand and the quality that is needed so that we can then proceed to commercial phase. So now we're in kind of a pre-commercial phase. We are selling small batches. We are having our products in test use in actual restaurants, cafes, also in supermarkets, and we are getting a lot of feedback from these customer trials. For example, especially on the sturdiness and then the insulation, grease resistance, and this really nice closure system that we have in the product. This we need to do as long as we have the confidence that the market demand is there and we can indeed move to commercial phase, so make an investment decision of a commercial plant. But so far, it's great that the demo plant enables all of these customer trials, and we can do quite high volumes of products for test and for sale, but obviously not yet in real commercial scale. If we take the next one. So what's next then? Certainly more work, continuing still with the work with customers and product trials, optimizing the product selection, the quality that we aim. We still need to work on the process, some key performance indicators there as well with Valmet. And then we need to plan the commercial plant. Where is it? How big is it? What products will it produce? How it will be, are there some phases to it? So this is ongoing work at the moment. And of course, the end game, the vision is that we would have very big Muoto production in Europe for various uses, the ones that I explained, maybe some other uses as well. And that we could make this a big enough business that it would really make a difference for Metsä, even though we're already quite a big company and have very, very large existing businesses at the moment. So we're aiming high with this. And if I still take the next one, I think it's my last slide. So here kind of connecting to the European agenda and the bioeconomy strategy. And we are definitely promoting, or the European Union is promoting and hoping to see the bioeconomy grow and thrive in the future. And certainly Muoto and other similar bio-based products really support that growth strategy. So it's local value chain starting from Nordic wood, coming from for example, the Äänekoski area in Finland. Traceable, certified, and I would love to tell you about our thinking around regenerative forestry relating to how the wood is harvested, how we can go even beyond the certification requirements in terms of nature management and biodiversity. But I don't have time for that, so you need to Google Metsä Group and regenerative forestry and you can read more. But that's a big, of course, question to ensure that the biomass is sourced in as sustainable way as possible and that we are actually improving the state of nature in the forest while we are using the wood. Then, as you already have heard, it's a product, bio-based product that can replace fossil-based products. So disconnecting us from the fossil value chain. But of course, as a product, it also needs to be circular and it needs to be recyclable. And this is what European strategies and goals are aiming for. So fully aligning with that. And we are shifting our focus in Europe in the scale-up phase. And very much we are concerned and want to ensure the competitiveness of Europe. And we are looking for these type of industrial projects where we can go and bring what is, where we are good at in R&D in Europe to actually make that commercial success. So this is, I think, an exemplary case of this industrial scale-up that we want to do in Europe. And overall, I think there is some solution here to European autonomy and resilience as well. Since we are disconnecting from the fossil value chains, we are using sustainably sourced biomass, and we have the whole value chain in Europe, including the technology supply. So many things kind of ticking the box what we are aiming with European bioeconomy strategy. That's all from my side. Let's see if there are questions.
So thank you to all the speakers for these excellent insights. Now we have some few minutes for questions from the audience. If I'm not wrong, we haven't received any from the chat, but please feel free to raise your hand, tell your name and your affiliation, and ask our speakers. Do we have any question from the audience? We have a question. Please, Elias, take the floor. And maybe, open your camera as well, that we can see you. If not...
Okay, hello.
Hello.
Hello. Yeah, I'm just wondering what are the benefits of this foam injection for foaming compared to conventional water-based systems? What lead to that solution?
Yeah, of course, we wouldn't be using it if there wouldn't be any benefits. So the most important thing is that it's enabling us to make this layering. It is kind of gentle way to carry fibers into the products, and it is also giving very good process controls how the basis weight or fibers are distributed within the product, kind of having good formation in the product. So they have it's more like we are making these end products with a precise manner. So those are the key things there. So the end product itself is not necessarily like porous or like including some air bubbles or so like styrofoam, not like that. But it is giving us the benefits in terms of using maybe some higher bulkiness fibers in the middle, and that way enables us to use less fibers in the packaging and still having like good stiffness, rigidity in the end products. Hopefully this answered your question.
Yes, thanks.
Thank you, Elias, for the question. Maybe the other speakers also want to comment.
Nothing to add. That's exactly what the foam enables.
Perfect. So is there any other question from someone else from the audience?
Hello, this is Jani Lehmonen from Fiberwood. So I have one question. So how do you see this scalability of this Sorry, now you can see my faces. So how do you see this scalability of this technology you have been developing from small scale to production scale? What kind of main steps and challenges you have found?
Very nice question.
So actually our demo line is already, in a way, the size of that is kind of commercial scale. But we have been finding ways to make the commercial line even faster. And using less space, things which help us to increase the operational efficiency, etc. So that's the key difference. The demo line itself has been more designed to be more flexible in case we need some adjustments there. So, but I would say that mostly the demo line concept is like it was designed in the beginning, and we had, of course, some lab phases and so on. But hopefully in the future we have capabilities to make even some little bit larger machines. So if we have now this forming area at 1200 by 800 millimeters, so who knows if we have even larger machines in the near future.
If I continue.
Thanks for the answer. Yeah, sorry,
Please.
Katarina.
And if I still continue from that, I think it's still good to understand that although Valmet may be able to make a larger machine, this is in the end still very much modular technology. So there won't be one machine the size of a paperboard machine that would make all the packaging in Europe, but it's very much modular. So you know, you have parallel production units. And that's a big difference actually to many other bio-based product developments and these kind of biorefinery projects where you need to build one huge line to make it profitable. But in this case, this is modular and you can grow it more gradually and not just bring to market absolutely huge volume of a new product at one time.
Yes, good addition. And of course, this modularity means, for example, that one operator can run several of those machines. So there is no need like one operator per machine or something like that, but they are commonly, or the whole plant is operated in one control system. Okay, thank you for your answer.
Just before we jump to Amrit's question, it was if I may comment, one of the striking elements in your case was the acceleration of the development. So your replies to that question and how you were so fast than other typical industrial timelines it was useful also answer also for the audience as well. And now we give the floor to Amrit for the question, please.
Sorry, now you can hear me, I think.
Yes, we can. Thank you.
Yeah, thank you, all the speakers. It was really, really interesting to see how the process went all the way from the basic research and now in this pre-commercial phase. So I work at the Joint Research Center of the Commission, and we look a lot at technology transfer. And so, yeah, very interesting. I was wondering, because Katarina, you mentioned you're still at the cusp of making that business decision of whether to commercialize or not. And I'd be curious if you could share what are kind of some of the main drivers, because I imagine cost parity with similar fossil-based products would be a big one, but whether there are also some regulatory barriers, because if it's, for example, food packaging, you would have to meet certain standards. And you also mentioned the recyclability, which I would be interested if you could expand a little bit on that. Thank you.
Yes, let's see now. On the regulation, yes, of course, super important to follow where that goes and make sure that you are compliant with it and hopefully even get the competitive advantage of it. However, in our case, how we see it now, we're still waiting for all kinds of, details to come up with the latest legislation, but it looks like that's no hurdles are coming up, and that's of course where we have been positioning the product to be compliant with the legislation, even though it's not all clear which categories and what are the details in there. The hurdles are very kind of typical. I mean, you know, in order to make an investment decision, you have to be confident enough that there is demand at a certain price point in which kind of enables the investment. So it's the investment cost, the price point, and the demand in volumes. That's where the math comes from, and you need confidence, and you can get confidence in various ways. The customer trials, you can have letter of intents, offtake agreements, all of the usual, and that you need to build certain level of confidence in order to make the investment decision. And that is very, very demanding phase, and of course, it's really important also that the costs, both the investment cost, the capex side, and the opex side, can be really minimized, because you're always you're disadvantaged with your cost structure because you're doing something new and you are starting small. So you can just imagine how established and huge a lot of the packaging industry in these areas is, and you're always kind of then competing against that. So it's the risk management from all possible sides, and then hopefully at some point we are then confident enough to take the step and make investment decision and start building the commercial line. And that's very much what we are aiming for. You also asked about the recyclability. I wonder if I know any details. Of course, that is super important, and it's according to the CEPI method how it is tested and approved. I don't know if there's much more that I can really tell, just not being the expert in there. But if you have any further questions, I'm happy to take it to my colleagues working with those questions on that topic.
Maybe to add from my side a little bit my understanding about the market situation. So during the past years, the US has been setting some anti-dumping duties for the Chinese and Vietnamese producers who are like exporting almost all of their production to Europe and the US. And what does it mean then for the Europeans? The US, they have the anti-dumping duties, so Chinese, Asian, Southeast Asian companies, they are now exporting to the Europe. And that's maybe concerning to these some basic plates and some clam cells or that kind of products. And unfortunately, these companies who are importing are not necessarily always playing the fair game what comes to the certification or things like that. So that's major concern. What I know that some of the molded fiber industry organizations have been raising up. Of course, in case of Metsä, they are luckily targeting to other end users as well. So it's not just the food service type of takeaway products. So it helps, hopefully.
Great. Thanks for your replies. And before we conclude our webinar, if we now turn to our VTT colleagues, to Jaakko and to Thomas, when you introduced this case, this success story, you said that you supported the project with fiber technology expertise and foam forming process expertise. So maybe could you please elaborate more on how long have you been maturing this technology so it can now be applied in these industrial processes?
Well, I can quickly start that. I think
Perfect.
we have been.
Thomas, you go.
Yes, so we have been doing this foam-based forming in several, let's say, joint projects. I would say previous 20 years, but actually I have not been at VTT when we have started this work. But we do have very long history, and if you just Google and look at the publications on that topic, you will find that most of the publications are from our place. Jaakko, if you have more insight on this, then please continue.
Yes, I would say that it's, you can say roughly 20 years, maybe the time span during which we have really researched and worked different properties and uses for foam. I mean, foam forming is one of those, but you can use foam in many other very clever ways as well. And it offers, like you also said, certain advantages compared to using the traditional wet process. And for instance, one of very interesting recent technologies that we've been promoting and are able to offer and develop further with our customers is using foam for application, meaning like, for instance, applying strength agents or coatings or barrier chemicals to a web, to a fiber structure in a very novel and extremely effective way. So foam is actually providing various kind of, you could say, superior properties or advantages compared to other processes, but you need to use it in the right places.
Okay, great. Thanks.
Did that answer your question?
Yes, it did. Thanks for your replies. And just to refer to you, if you want, we can share some extra material to all our participants of today's webinar, because they will receive a follow-up email and also sharing the recording, which will be available afterwards. So feel free to send to EARTO Secretariat any extra URL links or supporting materials that we can also forward it to our participants of today's webinar as well. So it's now time to conclude. Thank you so much to all our speakers. Ladies first, thanks so much, Katarina, Juho, Jaakko, Tuomas. Also, thank you, VTT, Valmet, and Metsä Group for sharing this inspiring collaboration story. And thank you also for all the attendees joining us today. As I said before, the recording will be available, and you will receive an email afterwards. And before we close, we invite you to stay connected with EARTO through our website and also channels on LinkedIn and also X. So have a nice afternoon. Bye-bye, everyone.
Thank you.
you.
Bye.
Bye.
Thank
Bye-bye.
you.
Thank you.
Bye.
Have a nice
Thank
day.
you. Bye bye.